Hello everybody. So here we will have some examples on image interpolation, and it will be practice and examples. Okay, let's go straight onto the topic. This is example 1. In example 1 we have, let's say that we had a 2 by 2 image. So this is a 2 by 2 image and it has been enlarged by factor of 5. It has been enlarged by factor of 5. So that means this 2 by 2 pixel has been stressed out, right? So if that is so this is 0, 1, 2, 3, 4, 5. So in this axis, x-axis, so it has been enlarged by 5, a factor of 5, and also in y directions we have 0, 1, 2, 3, 4, 5. So it is also has been expanded by by a factor of 5 or 5 times. So that means this 2 by 2 pixel, when we enlarge by by factor of 5, it now become 6 by 6 pixels pattern, 6 by 6 array size. So accordingly it has 36 pixel values, and it had 4 pixel values, and 4 pixel values were given, but here only 4 pixel values are given, but 32 values are missing. 32 values are missing. So we'll have to find those values. So in this example it says that find the values of T, U, V, W, that is T, U, V and W, using nearest neighbor interpolations. So there are many interpolation techniques, but this problem says that use nearest neighbor interpolations to find out the values of T, U, V and W. And of course, if we can find these values, we can find other values, in the same way. Okay, so how to do that is very simple. So let's use this tab. Okay, so this one, right? So the same one that I drew here. Okay, so it is very simple. What is the values of T? Because we'll have to use nearest neighbor interpolations. So the nearest pixel of this T is actually 10. So this value will be 10. Now what will be the values of U, that these values? So definitely this one is the nearest one, so it will be 30. What would be the V? So this is this one, that is 20. And how about the W, that these values? And we can see that this is the nearest to this one. So that means it will be 40. So that is simple. So just we use the nearest values. So we duplicate the values and we get the values at our expected points using nearest neighbor interpolations. Now it says another problem, the problem 2, find the value of f3 using linear interpolation given that f1 is 10 and f6 is 20. So this is a function. We'll have to calculate the values of the function at 3 given that the value of the function at 1 is 10 and the value of the function at 6 is 20. So graphically we can represent this one in this pattern. This I draw in this way, that we have given point 1, this point, that at, let's say, the very first point is, the given point is this one, right? At 1 it is 10. So let's say this is 1 and the value of the function, this is an arbitrary function, we don't know the function, just 2 points of that function are given. So this is at 1 it is given 10. And let's say this, we can imagine that this is x naught, the very first point is x naught, and at x naught equal 1, so this is maybe y naught. We can say this is y naught. The very first point is x naught and y naught, where x naught is 1 and y naught is 10. And we have given another point, that is this point, that let's say this is that point. So this point, perhaps let's say this point is 10, this point is 6, so we can say this is x1 equals 6, and the corresponding these values may be y1, we can say y1, and these values is 20. These values is 20. This values is 20. So we also we know that x1 and y1, this point, these 2 points are given, and this x0 and y0 is actually 110, and this x1 and y1 is actually 620. So this is it. So okay, now we'll have to find that the values at x equal 3, right? So before proceeding, let's draw a straight line. Just to, because we'll have to use linear interpolation, to find out the value of the function at f equal 3. So linear interpolations is actually concept of a straight line concept. So we can draw a straight line using these 2 given points. Like, so this is that straight line. Okay, this is that straight line. Now we'll have to find out the values of this function, let's say this one, values of this function at a point 3, that is, let's say x equal 3 now, and these values is, let's say, y. So that means we'll have to find that what is the values of y, ultimately, what is the values of y at x equal 3 at this point. So this is how we can do. So first let's see that this is the straight line. So think about that this point, that x1 point and x0 point, the two given points. Using these two given points, we can find out the slope of that straight line. And you know how to find out the slope of this straight line. If we use the point x0 y0 and x1 y1, if we use these 2 points, we can find out the slope of a straight line is, we make the difference on y-axis and then difference in x-axis. Just we divide, right? So how we do that then? So this is becomes y1 minus y0 divided by x1 minus x0. So this is the slope. And also you see that this point that we'll have to calculate the value for at this point is xy point. So definitely this point and this point also on the same straight line by definition, because in the same straight line. So how we the slope, we can also find the slope of the straight line using this point and this point as well. Now if we just take 2 points, one point is x0 y0 and another point is xy, then what is the slope? That slope will be y minus y0 divided by x minus x0. And definitely these two slopes are equal. So if we now solve, because we'll have to find out the values for y using the given points. So now what is the y? So you see, just we can rearrange this equation. We just rearrange this equation and we can find the values y equal y0 plus y1 minus y0 divided by x1 minus x0 multiplied by x minus x0. So this is the equation that we have. So this same equation we actually applied here. You see, y equal y0 plus y1 minus y0 divided by x1 minus x0 multiplied by x minus x0. So just we put the values that y0 mean the very first, the value of the function at the very first point is 10. Then y1 is the value of the function at the second point, that is 20, this 20, and then minus this y1 minus y0, again subtraction of the first point, and then distance between the first point and the second point, that is 6 minus 1, and then this one is distance between the expected point and the first point. So this is that's it. So this is if we calculate, this will be coming 14. Okay, so it is simple actually. But now let's look this equation, this equation in a little bit differently. We can find this equation a little bit differently. We can see that this equation a little bit differently. So for that I will write this equation but in a different form. How we can write the different form? You see, the different form is x1 minus x naught y equal y naught x1 minus x plus y1 x naught minus x. So it is the same equation. You see, it is the same equation we wrote. Just I rearrange again, right? I took this term, I took this terminology, this term, and multiplied this y naught into this one plus this one and that one, and that again you then multiply it with this one, you take that side change. So this is what this equation is. But these equations actually very helpful practically. How it becomes helpful? We try to understand that the intuitive way of this equation. Now what is this x1 minus x naught? Okay, to understand this one we'll have to again draw that one. So this is the very first point. This is the very first point. Let's say this one. This is the very first point, that x naught, and let's say this is y naught. And also we had this one, that is x1, and this is y1. Okay, this is y1. So what is this one? This x1, what is this one? This x1 minus x naught, x1 minus x naught, x1 minus x naught. This is actually the distance between these two, right? Distance between these two. Just remember, distance between these two. So what we are doing, we are just multiplying. So we are just multiplying. Okay, let me tell you in a reverse way. That is better. What is this distance? This x1 minus x. So x1 minus x, perhaps x is somewhere here. Let's draw the straight line also. This is our straight line we had, and let's say this one, our that one x, the point we want to calculate the values for. This is x. Now what is this one? x1 minus x. x1 minus x is basically the distance between these two. That the second point, distance between the second point and the point at which we want to calculate our function. Okay, so this is that distance. So now we just take this distance and multiply it by this y naught. That means we take this one, this y naught, and multiply it by this distance. Given that we want to calculate the values for y, right? Calculate for values for y. So how we do that? We take this one, this distance x1 minus x naught, and we multiplied by the values of at the first point, that is y naught. So we take the values of the first point at y naught, and then we take the distance that at the point we wanted to calculate the value to the second point, this distance, that is x minus x1, plus what we do now, we take now we take this one, this y1 is this one, this y1, this is the y1, and we multiplied by x naught minus x. So this is exactly this one, that is the distance on the other side from this point, the point we wanted to calculate the value. So that is x minus x naught, and this is exactly equal to our values y. This is exactly to our values y multiplied by the total distance. The total distance is x1 minus x naught. So how we can then calculate the value of y? It is very simple. Just we had 2 points. this point, we will take the y0 and multiplied by this distance and multiplied by this distance. Then we'll take the values of the y1 and then multiplied by this distance. Then we will divide this whole things by the distance between the given points, that is x1 minus x0. So we will be getting the values of y. So this is how we can calculate, we can calculate these values. We can also calculate these values. We can calculate these values f3. We already calculated in one way, but now let's we apply the approach that we learned in other form. So okay, let's do that. So what we have y0 is given 10, and y1 is given is the value at this other point is 20. Okay, so we want to calculate the values y. Okay, so how we do that? So y is exactly what will happen. We take this one 10 multiplied by the distance, so that means which distance we are meaning is the distance. So it's better I have a quick draw again. So this one is y0, this one is y0, this is x0, and this one is x1 and y1. And we want to calculate the values at this point, okay. So you see that 10, that means we take the values of the first values 10 and then this distance. So this distance is x1 minus x. So this distance, we already know that this distance is this distance is x minus x1, because this is 3 that we wanted to calculate, and this x1 is actually 6. So 6 minus 3. So 6 minus 3 is actually 3. So 10 multiplied by 3 plus we take now these values, that is 20, this is 20, multiplied by this distance, that is the x0 and x, the first point and the expected point. So this is again 3 minus 1, that is 2. So that is 2. Now divide by the whole distance. The whole distance is 6 minus 1, that is 5. So that is 5. So what it is now? It is now 30 plus 40 plus 5. This is 14. So the same values that we calculated, using here using this formula, just by having an analogical approach in some little bit different way, so we can more intuitive way, we can also calculate the values of the same values, that we can find the values of f3 at f3 using linear interpolations. So this is a very practical concepts. We can readily use this one in our image processing. So let's see the problem 3. So problem 3 is that the same, that image has been enlarged. Now we'll have to find the values of P. We'll have to find the values of P, Q, R and S. P, Q, R, S. We'll have to find these values. So you see that it is intuitive now. So how we can do that? We will use the same concept of linear interpolations that we did. So okay, let's I have the similar things here, similar diagram is here. So now we'll have to calculate, first of, let's say we wanted to calculate the value at the p pixel. Now what is the value of the p pixel? Now we already know that to calculate this value we'll have to use this 10 and this 40, because it's a linear interpolations. it's a linear interpolation, so we'll use this values 10 and 40 to find the values for p. Now to calculate this, we need the distance from this point to this point, so this pixel to this pixel, and we need the distance from this pixel to this pixel. But you see that this image has been actually enlarged by a factor of 5. Originally this pixel 10 and 40, they were actually close, just one step away. So we can say the distance between neighboring pixel is, let's say, 1. So if it is 1, but now there are some intermediate values, so what we can still assume the distance between this and that is 1. Okay, if that is so, then what is the distance between this pixel, the 10 and the pixel p? So what is the distance between these two? So this is 1 over 5. And the same way, the distance between the next pixel is 1 over 5. The same way is 1 over 5. The same is 1 over 5. And the same is 1 over 5. So because this increased a factor of 5, so the distance between each pixels now 1 over 5. Okay, so now what is the distance between this point and this point? This distance is 4 over 5. And what is the distance between these two? This is 1 over 5. So we can calculate the values of p very easily. We take 10 multiplied by 4 over 5 plus we can take this 40 multiplied by 1 over 5. So now and because the distance between these two, distance between 10 and 41, so if you divide by whole things by 1, it doesn't matter. Okay, so what the value for p is now is 40 by 5 plus 40 by 5, so 80 by 5, so 16. So the p is actually 16. So p is 16. Okay. Now what is the values for q? What is the values for q? Well, so q is this point. Now the distance between this is now 35 and distance between this is now 25. If it is so, the value of q is 10 multiplied by 35 plus 40 multiplied by 2 over 5. So we have 30 by 5 plus 80 by 5, so 110 by 5, and accordingly we have 22. So q is 22, or the values of the pixel q is 22. Now what is the values of r? What is the values of r? We can say that this is the distance and this is the r. Now the distance between these two is 2 over 5 and the distance between these two is 3 over 5. So the value of r is 10 multiplied by 2 over 5 plus 40 multiplied by 3 over 5. So if we calculate these things, then we will be getting 28. Similarly, if we calculate the value of s, it will be 10 multiplied by 1 over 5 plus 40 multiplied by 4 over 5, and it will be 34. So this is it, that we just use the same concept of linear interpolations to find the values of the missing pixels, or the pixels that the intermediate pixels. Okay, so now let's go for the next problem. Our next problem is use bilinear interpolations to find the values of t and u. Bilinear interpolations. Okay, and you remember the bilinear interpolations is we will use interpolations in both x-axis and y-axis. So simple. So if we first of all, let's say t, if we wanted to find the values of t. So how we find the values of t? It is very simple. First we will interpolate, because we will use interpolations in both x-axis and y-axis. So we need at least 4 values to find that one. So let's say we'll find the values for t. So the nearest four pixels is this one, this one, this one, and this one. So we will use these values to find out the values for t using bilinear interpolations. So bilinear means you see the t actually remains in this position, in these positions. So first we need the values for this one, and then we will use 30 and 20 to find the values of this one, and after that we will use these newly calculated values to find out the values for t. So let's apply then in the same way. Okay, so I take the same one now, this one. Okay, so 10 is, you see, so these values, we will find the values for t. What is this? We will use bilinear interpolations. So first we calculate these values, and we know that using 10 and 40, how we can find these values? Using linear interpolations. We already calculated, and that values is 16. And now how about these values? This 30 and 20, we can calculate the same way. That is 30 multiplied by 4 over 5 plus 20 multiplied by 1 over 5. So then we have 24 plus 4, that is 28. So this values is 28. Now it is again very simple that we will use this 16. We will use this 16 and 28 to find out the values for t. It is the same that now we will perform the interpolations on y-axis, right? We will perform the interpolations on y-axis. So how to do that then? It is very simple. So the value for t is then we take the 16 multiplied by 4 over 5, because this distance from here to here is actually 4 over 5, plus we take these values 28 multiplied by 1 over 5. So multiplied by 1 over 5. So if we do that 16 4 over 5 plus 28 1 over 5, so we can have 64 plus 28 divided by 5, so 18.4. So the values for t is actually 18 point. This is the values of t. Now how to calculate the values for u? So in the same way, right? In the same way, if you remember how to calculate these values, these values. So we'll find it in the same way. So let's again take the same thing, and u is this one, right? These values. So we'll have to calculate these values and these values first. So if you remember, the values of this one is the r values, right? This p and this was the q values was, if we go back, this q values was 22. So this is 22. and these values we can calculate is 30 multiplied by 3 over 5 plus 20 multiplied by 2 over 5. So what is these values then? 33 over 5, so that means 18 plus 8, so 26. So this is 26. So now we have ready for calculating u values. So these values is then 22 multiplied by, because this is this distance between these two is 2 over 5, plus take this 26 multiplied by 3 over 5 because the distance between this is 3/5. So this is then 1 is 44 plus 78 divided by 5 equal to 26.4, I guess. So you check it that what is the values is, this is 26.4. So this is the values for y. So this is how, bilinear interpolations. That means we are performing linear interpolations in both directions. So that's why it is bilinear interpolations. So now you can use nearest neighbor interpolations, linear interpolations, bilinear interpolations, and there are also, cubic and bicubic interpolations you can learn from yourselves. And thank you for watching this. So I hope it will be helpful for you. Thank you.